Today we're going to look at the law of sines and the ambiguous case. The ambiguous case comes from when you have two sides and the not included angle. And what happens is you have a scenario where you know this angle, you know this side, and then the placement of this third side, it could either not reach, that's called no triangle. You could have where it makes one triangle, that's nice because then it's only one solution, or you can have a scenario where you end up with two possible triangles, one like this and then one like this. And it's because this base, we don't have any defining characteristics of how long that is. So the problem, we're going to look at all three cases today. No triangle, one triangle, and two triangles. First case, we're going to make angle B 30 degrees, side B 30 degrees, and side A 72 degrees. So when I have a triangle like this, we've got A, B, and C, and this is 30, this side length is 30, and this side length is 42. So we're going to set up law of sines. Sine of 30 degrees over 30 is equal to sine of A over 42. We cross multiply, we get 42 sine of 30 is equal to 30 sine of A. Divide by 30. I'll use my calculator for this and find out that sine of A is equal to 1.2. Now in this scenario, because 1.2 is larger than 1, and if I try and do an inverse sine of it, it won't work. Does not exist because 1.2 is outside my range of sine. So this is an example with no triangle. Next case. We're still going to have 30 degrees for B. We're still going to have side length B as 30 units. But we're going to have side A be 24 units. So there's my A, my B, and my C. So we'll have sine of 30 degrees over 30 units is equal to sine of A over 24. Cross multiply, 24 sine of 30 is equal to 30 sine of A. Divide by 30. This comes out as 0.4 equals sine of A. We'll do an inverse sine on 0.4 and get that angle A is equal to 23.6 degrees. Now, I had said that there's possibility of having multiple cases. The reason that happens is because sine is positive in both the first quadrant, where that 23.6 is, and also in the second quadrant. Second quadrant angles from 90 to 180 are still possible in a triangle, just making an obtuse angle. So we need to find out what this angle is. He has a reference angle of 23.6, so I'm going to do 180 minus 23.6, and that comes out as 156.4 degrees. Now if I looked at that with my triangle, with my 30-degree angle, is that possible to have 156.4 and a 30 degree? While my triangle picture doesn't make sense, the angles also don't make sense because that adds up to more than 180, and we know a triangle has to be 180 degrees for all three angles. So that is not a possible angle, and so we have one triangle here. Last case, and as you may suspect, this one does have two triangles. So angle B is still 30, side length B is 30, and side length A is 42. So we're going to start with sine of 30 degrees over 30 units is equal to sine of A over 42 units. We cross multiply, 42 sine of 30 is equal to 30 sine of A. Divide by 30, we end up with sine of A is equal to 0.7. We'll do an inverse sine of 0.7. That's going to find out for us angle A. And our calculator gives us that quadrant 1 angle of 44.4 degrees. We think back to our unit circle. Well, not really a unit circle, but our different quadrants. Here's the 44.4 degrees. And we want to know what angle over here that would be. So we're going to do 180 minus 44.4, and that comes out as 135.6. So, scooching down a little bit, I could have a triangle with 135.6 degrees here, the original 30 here, and 42 and 30. Now, the reason this makes a triangle is 30 and 135.6, that's less than 180. So that's why I'm able to have a second triangle here. 165.6. So that means my last angle is going to be 14.4 degrees. So that's why we have two triangles here. So I have my first triangle with 30 degrees, 44.4 degrees, and 105.6.